Hello students, welcome to mathematics class. Students, this is part 5 of the chapter basic geometrical ideas. In this part 5, we will continue the learning of polygon, and further we will know what are the parts of polygon, and we will start discussing questions from exercise 4.2. Students, yesterday we have seen the meaning of a polygon, where to know what is the meaning or a definition of a polygon, I asked you to observe the following 5 figures: 1, 2, 3, 4 and 5, and I asked you what is the difference that you find amongst these 5, and I asked you, are they closed? How does each one of them differ from the other? And you could recognize yesterday that first 4, that is 1, 2, 3 and 4 are the closed curves made up of only line segments, and fifth one is not made up of line segments alone. Along with the line segments, it has got some curved portion. So that is the difference between first 4 when compared to the fifth one. Now these 1 to 4 are called polygons. That is what I mentioned you. Even I said a figure is polygon if it is a simple closed figure made up of entirely line segments. This is a bookish definition, but I gave you a simple definition called polygon is a simple closed curve made up of only line segments. I even told you what is the meaning of a simple curve by giving you on top these examples. These are not simple curves, where a curve is passing itself, crossing itself, certainly will not be a simple curve. It is a non-simple curve. So to call a polygon, polygon must be first a simple closed curve made up of only line segments. Then today we will continue this topic, but to continue this topic I want you doing some activity. Come on, let's begin the activity. Students, kindly collect matchsticks and try to form a polygon with the help of 5 matchsticks, then 4 matchsticks, and then 3 matchsticks, and then 2 matchsticks. Students, with 5 matchsticks I can form, so 1, 2, 3, 4, and suppose a big matchstick I have taken like this. It is a pentagon. We call it as a ಪಂಚಭುಜಿ ಅಂತ ಕನ್ನಡದಲ್ಲಿ, ಇಂಗ್ಲಿಷಲ್ಲಿ ಪೆಂಟಗಾನ್ ಅಂತ ಹೇಳ್ತೀವಿ. We call it as pentagon, where with the 4 matchsticks we could form like this. Chaturbhuji. In Kannada we call this, or in English it is called quadrilateral. Quadrilateral. Then with the 3 matchsticks I can form like this. You know, this is called triangle. Tribhuja anta kannadadalli ಹೇಳ್ತೀವಿ. So it is called as triangle in English. But can you form a polygon with the help of only two matchsticks? No, we cannot form. So, in this case, it is not possible. Okay, with the help of only two matchsticks, we cannot form a closed figure. So, polygon should have at least 3 line segments to get formed, I mean. Okay, now let's start with one more important topic called parts of a polygon. See children, here what are the parts of a polygon? Remember the word sides, the word diagonals and angles. Not vertices, only sides, diagonals and angles are parts of a quadrilateral, parts of a polygon. Examine this figure. This figure is made up of 5 line segments. Which are those 5 line segments? Line segment AB, line segment BC, line segment CD, line segment DE and last line segment EA. These line segments are called sides. The line segments forming a polygon called as sides. Next, there is a common point of any two line segments that you take here. Between EA and AB there is a common point. Between AB and BC there is a common point B. Between CB or BC we say and CD there is a common point. The meeting point or a common meeting point of a pair of sides is called vertex. Vertex is a point where sides of polygon meet, or a common point of two sides of a polygon will be called as vertex. Plural of vertex is vertices. So, we have sides EA and ED, EA and ED meeting at E. E is a vertex. Here A, B, C, D and E are vertices. Now, further, any two sides with a common endpoint are called adjacent sides. In a polygon, any two sides with a common endpoint are called adjacent sides. So, we have in this figure AB, BC one pair, BC, CD second pair, CD, DE third pair, DE, EA fourth pair, EA and AB fifth pair. So, there will be 5 pairs of adjacent sides in this pentagon. Remember children, how many vertices, that many pairs of adjacent sides. So, we have got a meaning of a pair of adjacent sides are any two sides with a common endpoint in a polygon. So, you can make this as a definition. Next, here are the sides AB and BC adjacent? Yes. Why they are adjacent? Tell me. Because there is a common point, isn't it? Since the point B is in common, is a common point, you can say even. Then how about AE and DC? No, they are not adjacent sides. So the endpoints of the same side of a polygon are called adjacent vertices. Endpoints of the same side of a polygon are called adjacent vertices. So a pair of adjacent sides, and we have got a pair of adjacent vertices. Now tell me, what do you call this AE and DC? They are called non-adjacent sides. So similarly, we have got non-adjacent vertices also. Which are non-adjacent vertices? For example, in this polygon A, B, C, D, E, you know A and B are the endpoints of this side, they are adjacent vertices. B and C are adjacent vertices. C and D are a pair of adjacent vertices. D and E is another pair of adjacent vertices. E and A is the another pair of adjacent vertices. So totally 1, 2, 3, 4, 5, 5 pairs of adjacent vertices we have got. Now tell me children, how I have got non-adjacent sides? Can I have non-adjacent vertices? Yes, we do have. A, C, they are non-adjacent vertices. A, D, non-adjacent vertices. B, D, non-adjacent vertices. B, E, non-adjacent vertices. C, E is another non-adjacent vertices. Already AC we have taken, so we will not consider that now. So I will change the color and draw this is joining of one pair of non-adjacent or not adjacent vertices. This is another. This is another. This is another. This is fourth one, I mean totally. This is fifth one. So if you observe 1, 2, 3, 4 and 5, it looks like a star na? Remember children, these are called diagonals. So what is diagonal? Diagonal is a line segment joining a pair of non-adjacent vertices. Once again I will repeat you the definition of diagonal. Diagonal of a polygon is a line segment joining a pair of non-adjacent vertices. Here how many such diagonals could you draw? I could draw 5. So AC, AD, BD, BE and C. So I have totally 5 diagonals. So, this pentagon is a special figure, remember children, it has got 5 sides, it has got 5 vertices and it has got 5 diagonals also. That is the specialty of a pentagon. So, it is not the same case with all the other rest of the polygons, okay, having equal number of sides, equal number of diagonals and equal number of vertices. And coming to the further, consider the pairs of vertices which are not adjacent. I have already explained you, I have already shown you this. The join of these vertices are called the diagonals of the polygon. I have already explained this. Is BC is a diagonal? Question. What is your answer? Is BC is a diagonal? No. Why no? Because B and C are a pair of adjacent vertices. A pair of adjacent vertices. So, BC cannot be diagonal. Now, if you try to join adjacent vertices, will the result be diagonal? No. If you try to join adjacent vertices, will the result be diagonal? No. Name all the sides, adjacent vertices of the figure A, B, C, D, E. So, all sides are AB, BC, CD, DE and EA. These are sides and adjacent sides AB and BC, BC and CD, CD and DE, DE and EA, EA and AB. So, total 5 pairs of adjacent sides. Now, adjacent vertices A and B, B and C, C and D, D and E, E and A. Total 5 pairs of adjacent vertices also. So, sides, adjacent sides, adjacent vertices. So, with this I have already told you the diagonal also. I have completed parts of polygon. Now, we will solve 1 or 2 questions of exercise 4.2. Now, coming to the question number 1 of exercise 4.2. Classify the following curves as open curve and closed curve. Is this is open curve? Yes, it is open curve. Is this is open or closed? It is closed. What about this? C is open curve. What about this one? It is a closed curve. This one is also a closed curve. Now, coming to the question number 2. Draw rough diagrams to illustrate the following open curve and closed curve. It's so simple. This is an open curve, and to illustrate B, it's a closed curve. Okay. Choice is yours. How to draw is yours. This is open curve and it is a closed curve. So, children, with this I will wind up this session. We will start from the question number 3 of the exercise 4.2 in our next session. Till then, take care of yourself. Jai Hind. Thank you.